All right. Hello, everybody, and welcome to the stream. My name is Nick Larson. Today is June 10th, 2019. It's about 3:05 in the afternoon, and we are going to do Mentorship Monday. All right, Mentorship Monday is becoming one of my favorite days. Let's see. There we go. We'll do it like this. And it's becoming one of my favorite days to update the stream while I'm streaming. Current question. Oh, shit. How do I edit? Give me the properties. All right. How to study effectively. Okay, perfect. Let's move that to the middle a little bit. There we go. Okay. You know, I think we can do better than this. No. Doesn't work like that, does it? No, it doesn't. Preview scaling. Transform. Reset. Oh, goodness me, that's small. There we go. Okay. All right, well, this is something I need to work on. Okay. Today's question, it was brought to me by Ryan Roberts, Cub Lover. He asked me, how do you prepare for a CS exam and how do you study for them? And that is a wonderful question. So I just got done going to school, getting my master's, and when I was there were quite a few tests, lots and lots and lots of things to prepare for and study for, and sometimes multiple things at the same time. And I really did have to practice to like hone in my skills as to exactly what it is that you need to do. Um, and here's just sort of like what I came up with. So, in general, when you're learning, you learn the fastest when you study the things that make the least amount of sense. So, to put this in like better terms, if you were playing like a game, right, you might win or you might lose. Like, let's say you're playing chess. You might get yourself into a winning position and you know it's won. You might get yourself into a losing position and you know it's lost. You won't learn anything on those. If you get yourself into a position that you think is won and then you lose, now you have a really great learning opportunity, right? Because your expectation of whatever the thing was totally wrong, right? And so what we need to do is fix that expectation. And by going after the places where your expectation differs from the reality the most, you're going to learn the fastest. And this applies really not just to games, but to anything. Um, let me put this. Let me give you another example. So in school, I took a class on AI. In undergrad, I wrote a poker playing robot. This poker playing robot performed horribly. Whatever. That wasn't really the point. I learned a lot in the process of building the thing. And then the trick is, as I was working through that, I had gotten to the point where my expectation of what was happening largely matched what actually happened, right? So I expected, based on the input that I gave it, for it to do certain things, and those certain things happened. So there wasn't really an opportunity to learn there. However, I go to grad school years later, a decade later, and start taking another AI class. In this AI class, I now am doing things that are very, very similar, implementing A star, going through and creating heuristics. And what I found was a lot of the stuff that I sort of took for granted for this last decade was just wrong, in a lot of cases. And the only reason I found out it was wrong is because I started applying it to different things, right? And so all of a sudden, this thing that I thought I knew and wasn't even worth studying because I I felt like I had a really good grasp of it. All of a sudden, I'm forced to use it for new kinds of problems, and I start to see a lot of the mistakes that I was making. So that's one of the things when you are studying, always take whatever it is that you're studying and apply it to a very broad range of things. Don't just stick to, the two examples that they give you in the book or the two examples that they give you in class. You need to take whatever it is that you're learning and you need to start applying it to as many different situations as possible, as many different problems as possible, and see what works, what doesn't work, what makes sense, what doesn't make sense. And then you need to sort of organize all of this and just focus entirely on the things that don't make sense. Um, that's that's the big overarching how to study. To get into a little bit more detail in specific instances, I had this pattern when I was preparing for a test or for an exam. And the way that it works is I sit down and I make a list of all of the topics that are going to be on the next exam, whatever it is. Okay? As you start going down the list, you start saying, okay, I understand this, I understand this, I don't understand this, I understand this, I don't understand this. You obviously want to focus on the ones that you don't understand the most, but don't just stop there. When you're describing your understanding of these things, start answering questions, just making up questions and answering them. Like, in fact, I'm gonna pull up one of the classes that I took and sort of show you kind of how I went through it. Give me just a second here. Gonna pull this up. I am logging in so y'all can't see. Yep. Two-factor authentication for everything. Okay. Let's see here. So let's take graduate algorithms. That was a fun one. Not really, but it was. I learned a lot. Let's put it that way. Okay. So really what I do is I'm like, okay, for the first exam, I know we have to go through, okay, DP is dynamic programming, right? Only there's a few things in here. There's, you want to say like, Fibonacci is one, but we don't actually care about Fibonacci. We also don't care about LIS or LCS. That's least common or longest common subsequence and longest increasing subsequence. We don't actually care about those in particular. What we care about is how they work, right? So we want to do prefix matching and we want to do suffix matching. And then we come down here and we're like, okay, knapsack and chain multiply. So two-dimensional problems. And then we want to do substring, or I don't know the right way to say this, infix matching, which is how you do matrix multiply. Okay, then shortest paths. Actually, forgot this one almost entirely. So then you would come in here and you would say like, okay, shortest paths, and just put a question mark next to it, let you know that, okay, I need to come back to this and go check that out. And literally this is it. This is all we're doing for like the top level. Then we're going to come down and we're going to say, okay, the next topic is randomized algorithms, randomization. And this is, oh yeah, modular arithmetic. If y'all aren't familiar with modular arithmetic, I highly recommend going and checking it out. Man, it is crazy. It is so interesting. The general gist of this is like, take extraordinarily large numbers and figure out how to multiply them, and then get the remainder of dividing them by other very large numbers. Okay, and do this efficiently. It turns out to be super, super crazy how you go about doing it. But so you have modular arithmetic, then you have RSA, and then you have Bloom filters. another fun one. And then I believe that was all that was on the first exam. So then you just come in here and you say, okay, prefix matching. You give a couple examples of prefix matching. So in this case, you have one like longest increasing subsequence. And then you come in and you say, okay, longest contiguous subsequence. All right, and the idea here is that now you want to basically describe how these work. On your exam, you're almost always given problems that map very, very, very closely to whatever it is that you are either given in the homework or something that you can find in the book or whatever. And the idea is that you want to know the inputs and the outputs to these things so that you can learn how to take the inputs to whatever the other problem is, convert it to inputs to a problem you know how to solve, and then take the outputs from that and convert it back into a solution for the original problem. And that's it. Like, you just got to practice that over and over and over. And I cannot stress that you just have to practice this. Start applying it to as many things as you possibly can. And then you sort of come down here, you're like, modular arithmetic. You know, what is it that I understand about modular arithmetic? What's the runtime? What is the runtime? What is the trick? Which is Euler, I think it's Euler something. Gauss's trick. Right? And just the key concepts that get you over the hill to be able to solve these things, and give them names. You know, having a name for something other than, oh, what is that trick? What is that trick? Like calling it Gauss's trick, and then you can actually go and look up the thing very, very quickly, very easily. Another thing that I don't really say a whole lot, but I should start saying more, is I follow this idea that if you have the words for something, all of a sudden it becomes enormously easier to just understand it. I give an example a lot of times when I tell people about it, about how to read people when playing poker. If you go meet somebody who's good at playing poker, if you have a poker game, you know, with your friends or whatever, and you go out, you know, you have some drinks, you play some poker. Eventually, like, one person or maybe two people are just obviously better than everyone else at the table. And so you go and you ask them, and you say, hey, how did you know I had that? And what they go is, oh, I just knew, right? And their idea is, I'm not going to tell you the answer. I'm not going to tell you how I knew that, because then you'll be able to, you know, trick me to not do whatever. But if you actually get them to talk about it, usually what you find out is they have absolutely no idea how they know. They just do, right? Your brain is this like magical device, and it does pick up on these patterns, right? But if I were to tell you the patterns, the things that you should be looking for, all of a sudden you cannot unsee it, right? I can tell you how to read people's faces very simply, and once I tell you how to do it, you will just not be able to unsee it. Talking to your wife, talking to your girlfriend, you won't be able to miss it. It's like it's almost like lie detection. You know, talking to your children, talking to your friends and your families. It's not like the end of the world to tell lies. Like, little white lies make, you know, a whole lot of things go away, and it's not that big of an issue. The trick of like being able to detect when somebody is lying is usually not like ooh, I got you sort of a thing. It's more like just a way for you to sort of encourage them to tell the truth more, right? So it's not a negative thing. When in poker, the whole idea is that if you can tell that somebody is lying, it totally changes the way that you think about the hand and that you would act in the hand, and usually to your benefit, right? Your brain, like I said, does pick up on these very small nuances over time if you play enough, if you watch other people enough, etc. But again, if I tell you how to do it, immediately you will just start seeing it all the time, right? That trick of like putting a name to something, having the words to describe something, I cannot stress enough like how amazing of like a life hack that is. So practice doing that. Even if you're just making up names for stuff, As long as it becomes something that your brain can tie back to, especially in the moment. I'm trying to solve a problem. I need to solve this problem. I've seen something like it before, but I just can't put my finger on it because you don't have a name for it. But if you had a name for it, it becomes so much easier to remember. Okay. And that is just a little rambling on, but trust me, practice that. It really helps. All right, so you go down, you make this list, you start really high level. What are the major topics we're going to cover? Like super high level. Then you start covering individual approaches for each of these things, right? That would be this like second level of indentation. Then you move into the things that you understand the least, and you start drawing, okay, here's all of the like individual problems that we have seen that I know about. And then these in here are the things that you want to spend the most time on, but you only want to spend the most time on the ones that you're having the hardest problems on, and you only want to spend the most times on these that you're having the hardest problems on at the highest level. Okay? You can pretty much just order things, go from top to bottom. I also follow a rule that like 90% of the grade is worth only 50% of the effort. Like to get that extra 10% requires another 50% of the effort. So don't stress yourself if you don't understand everything completely. Put a little bit of time into it, move on to the next thing. Put a little bit of time into it, move on to the next thing. If you're not understanding it, ask yourself if you don't understand it because it's too big or if it's because it's too difficult. If it's too big, break it down into a smaller problem. There was something we learned later on in this class, fast Fourier series, right here. Yeah, fast Fourier transform, right? This is an incredible algorithm. It has so many components, so many things that you have to learn. Same thing for RSA. RSA has so many components, so many things that you have to learn. But if you break it down, you find out that like each one of them isn't really that hard. It's just you have to remember to put them all together. Fast Fourier transform, exactly the same way. You have to know like 15 things, literally 15 things, in order to be able to understand what fast Fourier transform is doing. RSA, exactly same idea. There's not 15, but probably 12 things that you have to like totally have some sort of grasp of. And then at the end of the day, each one of those things individually isn't particularly hard. They're not trivial, of course, but they're not particularly hard. And so what you need to do is remember all of the parts. And that's why we're breaking it down like this. You get to RSA, you start breaking RSA down into parts, right? The first thing I need to do is I need to make sure modular arithmetic is actually part of that. The second thing that you want to do is get in there and say like, okay, we need a potential function, and then we need how to calculate the key, how to find a valid public key, right? And you just break it down into parts, and slowly but surely each one of these things turns out not to be like the end of the world, right? So don't think of things as like huge, enormous problems, have to understand all of this. If you understand like 9 out of the 12 things, you have a really good chance of doing well on your exam, right? If you don't understand 12 out of 12, it's just not the end of the world. But if you can sit down and you can grind out individual parts of it, you're going to get like 90% of the credit. You'll get A's, right? And if you don't get A's, you'll get B's. And, you know, at the graduate level, or sometimes even at the undergraduate level, like, it doesn't even matter whether or not you do well on the test or not. All that matters is that you do better than the other people in your class. Just remember that kind of stuff. You know, always optimize for what it is that you have to do in order to succeed. And then don't think of yourself as having to be the top of the hill, right? You want to be the top of the hill in like 3 things in your entire life. And everything else, you want to know well enough to be like proficient at it, to make some advancement, be able to use these things in a setting beyond the one that it was introduced to you on, be able to apply it to other problems. And then that's just good enough, right? Like, I don't need to know how to make a hammer. I don't need to know the coefficient of how heavy it is to how big of a nail it is that I can hit. Like, I just need to know how to swing a hammer to put a nail and, hold some pieces of wood together. Like, that's all that matters. That's all I'm being graded on. Do these two pieces of wood stick together? Yes or no? The fact that I understand every little detail about how all of it works isn't super important for like 99% of problems. At least not the ones that you'll be solving in your life. For the ones that you absolutely must know that stuff, then go learn that stuff, right? But like, just learn how to swing hammers, learn how to drive a car. Don't worry about how the engine works, you know, most of the time. If you're building cars, if it's your job to design cars, then you go learn how the engine works and how to build them and how all of that stuff works. But for the most part, like, get an introduction to it, have a general idea. I know that there is a giant thing called a block. Explosion happens in there, it pushes a piston, the piston spins a rod, the rod spins the tires. Like, that's about the level of understanding that you really need for most things. And then beyond that, like, yeah, just figure out whatever it is that you need to use. Um, let's see. So yeah, you just kind of break it down, really focus on the stuff that you don't know the most, and then don't try to create new knowledge. Like, for a test, not when you're studying for a test. That's not what that's for. Like, creating new knowledge in this world is for doing research and that sort of thing. Don't worry about trying. They just want you to understand the concepts. They want you to be able to apply the concepts. Usually, your tests will still be learning experiences because you'll be seeing problems you've never seen before, and you'll have to apply some really interesting techniques that you've learned in your class to them. But, like, that's it. Don't expect to see problems that you've seen before, and just be well enough in tune with the things that you're supposed to know to be able to apply them to the problems that you have. I hope that's useful for everybody who's here. Thanks for coming and hanging out. If y'all have questions, I'm going to hang around for about 5 or 10 minutes. Happy to answer anything specific that you might have. Consider this like, basically an office hours if you want to. And yeah, that's it. That's how I studied for tests. I got all A's in grad school. So there were a couple of times where I was like very, very close. I didn't get A's on every test. I got A's in every class. I should be very specific about that. Yeah, but I hope that was useful. Let's also give a shout out to the people who gave me follows while we were away. That is Kurihoyo, Underground Aesthetic, iKit57A03. And yeah, thanks everybody for following. Yeah, please do ask questions. Consider this open office hours. And yep, that's pretty much it. All right. All right. I think that's about it. Let me very quickly find somebody who we can throw a raid to. We're going to go with Brandon Satram. All right. And here we go. Thanks again. I'll see y'all everybody later.